Hello, class. This is Mr. Hart. In this podcast, we want to talk about dark matter versus dark energy. Now, you should have already watched that video by Physics Girl. She does a great job of explaining what dark matter is and how we learned about it and all that stuff. But I just want to quickly talk about how I distinguish between dark matter and dark energy. Okay, so we can kind of make this table to help us organize what's going on. Okay, so let's start by talking about baryonic matter, which is what we would call just matter, normal matter. Okay, and baryonic matter only makes up about 6% of the universe. Okay, so not a whole lot. Okay, even all the stars, all the planets, everything on Earth, all of that together only makes about 6% of the universe. Compared to dark matter and dark energy, they take up a lot of the universe. So dark matter makes up about 26% of the universe right now, if I'm not mistaken. The estimates usually change. And dark energy makes up about 68% of the universe. Okay, so only a tiny fraction of what we get to see is actually what the universe is made out of, which is kind of interesting. We'll talk about what that means in a second. Okay, so does it interact with light? Well, obviously yes, because we can see the matter that we can see. That's kind of intuitive. Anyways, and then the direction of the gravitational force for regular matter is always towards the object. Okay, it always pulls in towards the object. Okay, so hopefully that's not surprising. That's the matter we interact with every day. Compare that to dark matter. Now, the reason they call it dark matter is the dark indicates that it doesn't interact with light. Okay, so there is no interaction with light, which is why we call it dark. We can't see it. Light just kind of passes through it. So we still know it's there, though, as explained in the previous video, because of the gravity that it has. It has a strong gravitational pull on other objects, so we know something has to be there. It's just not interacting with the light we see. Okay, so the gravitational pull is still towards us with dark matter. Okay, and there's a lot of it. We can see that from gravitational lensing and other things like that. Last of all is dark energy. Okay, now they call it dark because it does not interact with light. Okay, so we can't see it from light interactions. And they call it energy because it has this really weird property. Okay, it actually doesn't pull towards the object. It actually pushes away. Now, where do we come up with this idea of dark energy and all this stuff? Okay, well, part of it comes from the idea of the expanding universe. Okay, now according to the Big Bang, all the matter in the universe was in one spot, basically, because it didn't have any space yet, and then space expanded and all these things started moving out very quickly. Now, if you just think about gravity in this case, there was a lot of energy that pushed stuff out initially, but this energy this gravity should be pulling things back in eventually. So there used to be this theory called the Big Crunch, that all the energy and matter in the universe would push out from the Big Bang and then come back in for the Big Crunch. It would just kind of oscillate back and forth, expanding, compressing, over and over and over. They called it the Big Bang, Big Crunch idea. Okay, but what they found was really surprising. They did some experiments. They used the Doppler Effect, which we talked about in our wave unit, and they actually looked at planets that were going far away from us and stars, and all of them were redshifted, meaning they were all moving away pretty much. There's a couple that are blue shifted, but overall, they found that the universe is moving away from us. And not only that, it's moving away and it's getting faster and faster and faster, which doesn't make any sense. If there's all this gravitational pull from the objects, they should want to come back together, but instead they're moving farther away at faster and faster speeds. And they calculated and figured out, well, for this to be the case, there must be some type of energy, some type of force that's pushing things away from each other, and there's a lot of it. Okay, based on the numbers we're getting, there's a lot of that is occurring. So we don't really have a good idea of what dark energy is yet. There's a lot of theories about how it could exist and all these different things. But all we know is it doesn't interact with light, and it's causing things to move away from each other. The gravitational force is expanding things. Okay, so there you go. Those are the three different types: regular matter, which does interact with light; dark matter, which doesn't interact with light but still pulls in; and dark energy, which doesn't interact with light but pushes away. Okay, and that's the distinction. That's how I like to keep them separated in my head. That's a very oversimplification, but overall that will help you kind of distinguish when you read the news and stuff like that what they're talking about. Alrighty, but that's it for this podcast. Let me know if you have any questions, and thank you for watching.